Assalamualaikum. So ini sambungan daripada video tadi. Okay, so finally kita akan belajar tentang probability lah. Okay, yang tadi yang dalam video yang sebelum ni hanya tentang rules ataupun ada tentang combination, permutation. Okay, belum masuk betul-betul dalam probability, di mana probability of an event. Okay, the symbol is P. Okay, P in a bracket the number of the name of event. Okay, kalau event tu nama dia A, so PA lah, kita ada PA. Okay, the formula is P event equals number of event divide by number of sample space. Okay, eventnya ada berapa bahagi dengan sample space dia ada berapa. Okay, example. Okay, what is the probability of getting number 5 from experiment of tossing a dice? Okay, so our sample space is 1 until 6. Okay, and our A, event A, what is the event? Event dia kata nak getting number 5. Okay, so the outcome for event A is 5. Okay, so dekat sini kita nak kira probability of A equals, okay, number of event, kat sini ada satu event, number of event kat sini ada satu, kat sini ada 6. So 1 divide by 6. 1 over 6 lah jawapan dia. So PA equals 1 over 6. Okay, second example. A coin is tossed once. Okay, so what is the probability of getting a head? So ini adalah event kita. Kita nak cari P, probability of getting head, PH. Okay, so kita kena list down what is our S, sample space. Our sample space is H and T, which is head and tail. Head and tail. So the probability of getting a head is H lah. So ada satu kat sini, ada dua. So PH equal 1 over 2. Okay, next. A coin is tossed twice. Okay, so our sample space will be kita baling coin tu 2 kali. So whether kali pertama kita dapat head, kali kedua dapat head, ataupun dapat head tail, ataupun dapat tail head, ataupun tail tail. So this is our sample space, which is kita ada 4 dekat sini. Okay, and then event kita adalah dia nak 1 head occurs. 1 head. 1 head maksudnya yang ni lah. Ada 1 head yang ni. Yang sini ni yang ni. Okay, HT dan TH. So ada 2 dekat sini. So probability of 1 head occurs is 2 divided by 4, which is 1 over 2 lah. Okay, so ini solution dia. Okay, next, the properties of probability. Okay, probability, the value of probability must be between 0 and 1. 0 and 1. Okay, so you all boleh nampak dekat sini jawapan dia 2 over 4. 2 over 4 is 1 over 2 equals 0.5. Okay, it is between 0 and 1. Example yang ni pun tadi, 1 over 6, 1 over 2, semua value dia between 0 and 1. So each time you compute for the probability, your answer must be between 0 and 1. Kalau not between 0 and 1, it means that your answer is wrong. And then the sum of probabilities of all event or outcomes of an experiment is always 1. So contohnya kalau kita ada banyak event, okay, banyak event, so the probability of all the event, kalau kita sum up, tambahkan semua, mesti equals 1. Okay, mesti equals 1. Kalau kita ada banyak event, probability semua kita tambahkan mesti 1. Okay, and then kita ada additive rule kat sini. Okay, kita ada 2 rules all together. Okay, the first rule is for if A and B are any 2 events, then Probability of A union B equals probability A plus probability B minus probability A intersect B. Okay, so ini formula dia. The first formula. Second formula is also for probability A union B. You all tengok sini probability A union B, ini pun probability A union B. Tapi what's the difference between these two formulas? Okay, the second formula is for if A and B are mutually exclusive. Mutually exclusive. So kita guna formula ni. Kalau A and B are not mutually exclusive, kita akan guna formula yang ni. Okay, apa maksud mutually exclusive ada dalam first video. Maksudnya antara A dengan B, there is no common element. Tak ada elemen yang sama antara A dan B. Okay, so kalau dalam A dengan B tak ada elemen yang sama, so kita akan guna formula ni lah untuk cari probability of A union B. Okay, so the formula dua-dua ni lain. Okay, bezanya untuk second formula dia tak ada yang ni. Tak ada yang ni. Sebab apa tak ada yang ni? Sebab A and B are mutually exclusive, meaning that there are no common element. Tak ada elemen yang sama. So maksudnya kalau kita nak intersect A intersect B, jawapan kat sini adalah 0. Jawapan kat sini 0. Sebab tu formula dia jadi yang depan ni saja. Okay, untuk yang ni. Okay. So example, in a high school class of 100 students, 45 studied maths, 69 studied history, and 35 studied both maths and history. If one of these students are selected at random, find the probability that, okay, question A, the student took maths or history. And question B, the student took history but not maths. Okay, so before doing the solution, we need to list out all the hints given. Okay, the first hint is dia bagi dekat sini 45 students studied maths. So the probability for maths, P maths is equal 54 divided by 100. Okay, and probability for history, P history equals 69 divided by 100. Okay, and probability for maths intersect history. Kenapa intersect kat sini? Sebab 35 students studied both maths and history. Dia study dua-dua. So maths intersect with history equals 35 over 100. Okay, so the first question is we want to find the probability for students to maths or history. So the symbol of OR is union. Okay, so meaning that we want to find probability for maths union history. Okay, like this. Okay, so kita nak guna formula yang tadi. Okay. You all compare. Kita nak guna formula yang ni, this one. Okay, so kita compare our A ni adalah maths, B ni adalah history lah. So just insert into this formula. Okay, so kita akan dapat P maths, okay, P maths plus P history minus P maths intersect history. So akan dapat macam ni. Okay, ini kita guna formula yang ni. Okay, and then just insert all the values that we got. P maths is 54 over 100 plus P history is right here, 69 over 100 minus P maths intersect history is right here, minus 35 over 100. So the answer is 22 over 25 or 0.88. So we can see here our answer is between 0 and 1. Okay, probability mesti antara 0 hingga 1 jawapan dia. Okay, number 2. Okay, B, question B. The student took history but not maths. Okay, but kalau ada nampak but tu maksudnya maksud dia sama dengan simbol N simbol N. So we need to find probability for history and maths complement. Okay, maths complement means not maths. Okay, bukan matematik. Maths complement. Okay, kalau you bayangkan kita ada Venn diagram kat sini. So this is the set for history and this is the set for maths. Okay, history dengan maths dia ada overlapping dekat sini sebab ada 35 students study maths and history. So 35 students adalah termasuk dekat sini, overlapping part. Okay, kita back to this question. Okay, kita nak cari probability for history. Okay, history is saya lorikkan history is right here. And not maths, yang bukan maths. Okay, bukan maths maksudnya yang ni lah. Bukan maths, bukan dalam set maths. Okay, so history is the region shaded in color orange. Okay, not maths is shaded in red color. Okay, red color. Okay, red dengan orange. You all nampak tak perbezaan color? Okay, so kita nak cari intersection between orange and red. Okay, nak cari intersection. So intersection part tu maksudnya kita nak tengok yang region mana yang ada dua-dua color orange dan red. Kat mana region yang ada orange dan red? So tengok betul-betul region yang mana yang ada dua-dua color di sini. Region yang dekat sini ada both color red and orange. Okay, so maksudnya soalan ni dia suruh kita cari probability dekat region yang dekat sini, yang saya dah colourkan biru ni. Okay, macam mana nak dapat ni? Okay, so the solution is probability maths union history. Maths union history tu maksudnya semua dekat sini. Okay, maths dan history, dua-dua bulatan ni. Minus probability maths, tolak yang bahagian maths. So kita akan dapatlah bahagian biru. Okay, saya ulang. Ni semua probability maths union history. Maths union history means that all the region right here and right here. Okay, ni semua minus yang maths, minus maths. So kita akan dapatlah yang color biru. Okay, so kita akan gunakan formula ni lah. So probability for maths union history is given right here. Okay, so kita ambil je jawapan dia kat sini. Minus probability maths ada kat sini. Okay, so dapat jawapan 17 over 50, which is 0.34. Okay, next, independent event. Okay, what is the meaning by independent event? Okay, consider that we have two events, A and B. So we call A and B are independent if it satisfies this formula. Probability of A intersect B equals probability A multiply probability B. So kalau dia satisfy this formula, so we can say that event A and event B are independent. Okay, kalau dia not satisfy this formula, so kita kata event A and event B are not independent. Okay, kita tengok example. Given that probability for event A is 0.54, probability for event B is 0.69, and probability for event A intersect event B equals 0.35. So show that event A and B are not independent. Not independent meaning that it will not satisfy this formula. So kita nak tengok dia satisfy, not satisfy, kita kena carilah probability of A intersect B is given right here, which is 0.35. Okay. So kita tengok dia equal tak dengan probability A multiply dengan probability B. Okay. So probability A given 0.54, and kita kena multiply dengan 0.69. Okay, multiply. So dapat jawapan 0.3726. It is not equals to 0.35. Okay, so it is not equal. The formula is not satisfied. So we can conclude that A and B are not independent event. So next, the conditional probability. Okay, probability maksudnya apa tadi? Kebarangkalian yang ada conditional, yang bersyarat. Okay, the probability of event B happening given that A has happened. Okay, kita nak cari probability of event B, tapi event A dah berlaku. So notation dia adalah P B, ada palang kat sini BA. P BA. Okay, maksudnya kita nak cari probability of event B given that A has happened. Okay, so macam mana nak cari P BA? So formula dia ini. PA intersect B divide by PA. Okay. For example, suppose that the probability of scheduled flight departs on time is PD equal 0.83. So D ni maksudnya depart depart. So this is the probability for event the flight was depart, 0.38. And the probability that is departing and arriving on time is P A intersect D equals 0.78. A intersect D. A is arrival, and D is depart. Okay. So 0.78 ni adalah probability of arrival and depart. Ada perkataan and sebab tu dia letak intersection dekat sini. Okay. So calculate the probability that the aircraft arrives on time given that it depart on time. So calculate the probability, maksudnya P, probability of what? Of the aircraft arrive. Arrive tadi kita letak A kan? Arrive on time given that, so dia ada palang kat sini, given that it depart on time, D. So kita nak cari PAD, yang ni lah. So using this formula, so kita akan dapat P D intersect A divide by PD. So given that PD intersect A equals 0.78 right here, so we need to divide it with 0.83. So the answer is 0.94. Okay, next example. The probability of a father watch al-kuliah is 0.5. Okay, father, so kita letak F So PF is 0.5. And a son watch the same program is 0.4. Okay, son kita letak S So our PS equals 0.4. The probability that both be a father and son watch the program is 0.28. So father and son maksudnya probability of father and son equals 0.28. Okay, so dia ada bagi 3 hint dekat sini. And then the answer is, what is the probability probability that the father watched the program given that his son watched the same program. So kita nak cari PFS. Jangan terbalik bukan SF, FS. Sebab given that ni dekat belakang. Okay, so kita nak cari PFS, masuk dalam formula yang tadi, PF intersect S divide by PS. So PF intersect S dia dah bagi 0.28 divide by 0.4. So the answer is 0.7. Okay. Selain menggunakan formula untuk cari probability, kita ada lagi dua cara. Okay, nak cari probability, iaitu menggunakan first tree diagram, and then second is Bayes theorem. Bayes theorem. Okay, kita tengok dulu macam mana nak cari probability menggunakan tree diagram. So first we need to know what is tree diagram. Okay, a tree diagram is a graph that is helpful in organizing calculation that involve several stages. So this is the example of tree diagram. So we can see here each segment in a tree is one stage of the problem. So kita tengok dekat sini adalah segmen, dekat sini adalah segmen. Untuk tree diagram dekat sini ada dua segmen. Dua segmen means we have two stage ataupun two event. Okay, ada dua event. Setiap satu stage ni ataupun setiap satu segmen ni untuk satu event. So ini second event. Okay, and the branches of the tree diagram are weighted by probabilities. Setiap branch dekat sini, okay, kita kena letak probability. Sini probability, and then branch ni ada probability, branch ni pun ada probability. Setiap branch mesti ada probability dia. Okay, example. Draw a tree diagram to show the result from an experiment of tossing a coin once. Baca betul-betul soalan ni ada berapa event? Ada satu event saja, iaitu tossing a coin once. Okay, so dekat sini kita ada satu segmen sajalah dekat sini. Okay, because we have only one event, okay, which is tossing a coin once. So kita punya tree ni hanya ada satu segmen lah, iaitu ada dua branch. Okay, so tossing a coin once, kita ada two outcomes, which is head or tail. So dekat sini kita ada PH, probability for head equals 0.5 and probability of tail equals 0.5. Okay, kenapa 0.5? Sebab dia bahagi kepada 2 saja. Okay, which is dekat sini total mesti 1. So total mesti 1. So kalau bahagi dengan 2, each one ni adalah 0.5 lah, 0.5. Okay, different with example 2. Okay, draw a tree diagram to show the result from an experiment of tossing a coin twice. So kita ada dua event dekat sini. Event pertama adalah first toss, event kedua adalah second toss. So dekat sini kita ada dua stage, sini dengan sini. Okay, ataupun dua segmen lah dekat situ. Okay, untuk first stage kita bahagi kepada 2 lah. Okay, first toss, kenapa bahagi kepada 2? Sebab ada dua outcome, whether it is head or tail. So PH equal to 0.5, PT equal to 0.5. And then untuk second toss, each of this branch will be divided into 2 outcome jugalah. Okay, and this branch is also divided into 2 outcomes. Okay, dekat sini adalah PH. Sebab apa? First toss dia dapat head dekat sini kan. First toss head, so depan dia mesti head lah. Dekat sini tak apa, kat sini saya ajar you all tulis lain sikit. Okay, dekat sini adalah PH, ini PT. PH, PT. Okay, maksudnya first toss here is head, and then second toss dia dapat head lagi. Ataupun first toss dapat head, second toss dapat tail. Kat sini first toss tail, second toss head, first toss tail, second toss tail. So each of this 0.5. Okay, 0.5 ini equal 1, sini pun equal 1. Okay, so kita ada dua stage kat sini lah. Ini adalah untuk first event, and then this is for the second event. Okay, and then kita nak cari probability. Okay, dekat sini untuk line yang ni kita akan dapat P H intersect H. Kenapa H intersect H? Sebab here is H and H. H intersect H. Okay, probability of H intersect H is 0.25. Kita darabkan 0.5 darab 0.5, 0.25. And then PH dengan PT. Jadi PH intersect T. Okay, 0.5 darab 0.5 akan jadi 0.25. Ini pun samalah, dekat sini kita akan dapat PT intersect PH. Okay, PT intersect H. Ini PT intersect T. Okay, so itu cara nak buat tree diagram untuk yang ada dua event. Okay, kita tengok example kat sini. Okay, when Puan Siti, a businesswoman, needs a taxi, he hires from 3 firms, X, Y, and Z. Of her hiring, 40% are from X, 50% are from Y, and 10% are from Z. For taxis hired from X, 9% arrive late. The corresponding percentage for taxis hired from X and Y being 6% and 20% respectively. Okay, so the first question is you need to draw a tree diagram for the above situation. Okay, so the solution is here. Okay, so dekat sini kita ada dua stage sebab kita ada dua event. First event adalah dia hire taxi. Okay, daripada firm XYZ. Second event adalah taxi tu lambat. Okay, so first stage kita ada firm daripada firma XYZ. Nanti kat sini kita akan bahagikanlah dekat bawah ni XYZ. Stage tu adalah event yang taxi tu late ataupun not late. Okay, so dia akan jadi macam ni. Okay, so this is the first event. Okay, dia hire taxi from firm X, Y, and Z. So kita ada probability X, probability Y, and PZ. Okay, PX 0.5 sebab dekat dalam statement tadi dia kata PX dia adalah 40%. Okay, 40%. X 50%, Y 10%. So kita letak dalam bentuk point. Okay, akan jadi macam ni lah. PX 0.4, PY 0.5, PZ 0.10. And then each of this branch, okay, event pertama dia ada 3 branch sebab ada 3 firm. And then each of this branch dia bahagi kepada 2 pula. Sebab apa? Sebab ada 2 probability, iaitu sama ada taksi tu lambat ataupun taksi tu tak lambat. Okay, untuk X, kalau taksi tu lambat, probability dia 90%. Okay, dia bagi kat sini. Okay, untuk X 9% lambat, untuk Y 6% lambat, untuk Z 20% lambat. Okay, lambat. So dekat sini 0.09 sebab dia kata tadi 9% lambat. So kalau 0.09 late, yang akan jadi not late adalah 0.91 lah. Okay, untuk Y dia kata dekat dalam statement tadi yang late dia adalah 6%. So which is 0.06 late, and not late 0.94. For taxi Z from firm Z, late 20%, not late 80% lah. Okay, so untuk first stage dia bagi pada 3 because we have 3 firms. And then for the second stage of this branch divided into two branch lah, 2 branch, sebab kita ada 2 outcome sama ada late or not late. Okay, untuk dekat sini, okay, kita kira lah 0.4 multiply with 0.09 equals 0.039. This is the P X intersect late. X intersect late. for probability X intersect not late, okay, dia akan jadi 0.4 times 0.91, okay, which is this one lah. Okay, untuk probability of Y late, okay, Y late 0.03, Y not late 0.47, Z late 0.02, Z not late 0.08. Okay, so this is our tree diagram lah untuk soalan tu. Okay, and then second question, tengok balik dekat sini. Dia kata, given that she calls for a taxi and it arrives late, what is the probability that it came from Y? Okay, kita tengok Y saja dekat dalam tree diagram kita. Okay, untuk Y okay, maksudnya dia kata dia nak probability dia from Y yang late. Okay, so Y late ini guna formula P Y late equal to probability Y intersect late divide by probability late. So probability Y intersect late kita boleh dapat daripada sini lah, 0.03. Okay, probability late daripada sini, late 0.9, 0.94. Sorry, ini not late. Late dia nak late saja. Yang ni dengan yang ni. So kita tambahkan semua. Sorry, bukan. Salah. Sorry Okay, untuk probability late yang ni, kita tak ada kaitan dengan sini lagi. Kita ambil yang nilai kat sini saja. Okay, untuk late yang ni dengan yang ni. Okay, tambahkan semua. So dapat jawapan 0.3488. So our answer is still between 0 and 1. Okay, so itu nak kira daripada tree diagram. Okay, so we have another one method to find the probability, which is using Bayes theorem. Okay, untuk formula Bayes theorem, kita nak kira macam ni jugalah, yang dia ada palang kat sini. Okay, which is untuk yang tree diagram kita guna formula ni. Okay, formula yang ni kalau guna tree diagram. Okay, tapi kalau guna Bayes formula, kita still nak kira benda yang sama, yang ada palang kat sini tapi formula dia lain, iaitu yang ni. Okay, so PAB equals PA, probability A, darab probability BA, bahagi probability A darab probability BA, tambah probability A complement darab dengan probability BA complement. Okay, so kita ini, you all boleh tengok example ni adalah the same question as previous. Okay, sama macam tadi, tapi kali ni kita nak guna Bayes theorem untuk soalan yang nombor 2 tadi. Yang ni, given that she calls for a taxi and it arrived late, what is the probability that it came from Y? Okay, tapi this time kita nak guna Bayes theorem. Okay, yang tadi kita guna apa tadi? Kita guna formula yang lain. Dapat jawapan 0.3488. So this time using Bayes theorem dapat jawapan sama, tapi formula dia lain. Okay, so you all boleh tengok dekat sini. Kita substitute into Bayes theorem. So PY late equals PY darab P late Y divide by PX multiply P late X plus PY multiply P late Y plus PZ multiply P late Z. Okay, so dekat sini PY ini semua kita dapat daripada tree diagram tu tree diagram. So PY dengan P late Y yang ni lah. Okay, PY yang ni, PY P late Y yang ni. Okay, 0.5 darab dengan 0.06. Okay, 0.5 multiply with 0.06. Okay, PX carilah dekat dalam tree diagram. Yang ni pun semua dapat daripada tree diagram. So selesaikan dapat jawapan yang sama. Okay, so if that question required you to use Bayes theorem, so you need to use Bayes theorem. Okay, kalau dia tak mention about Bayes theorem, you can use ordinary formula. Okay, let's look at example 2. Okay, a fruit seller received 80 boxes of orange from the fruit dealers during a festive season. Out of the 80 boxes, 20 boxes were delivered by dealer R, 50 boxes by dealer S, and the rest by dealer T. Okay, from past experience, the fruit seller observed that 3%, 7%, and 10% of the oranges delivered by dealer R, S, and T respectively are rotten. Rosak, So, draw a tree diagram. Okay, so in this problem, we have two stages. The first stage is for dealer, which is we have 3 dealers here, R, S, and T, R, S, T. And then stage 2, rotten, orange, yang rosak. Okay, so kita punya tree diagram will be like this. Okay, for the first stage, kita divide into 3 branches. The first branches is for R, S, and T. Okay, so here we have PR, PS, and PT. For PR, okay, PR 20 over 80. Yang mana? 20 over 80. Ni 20 boxes were delivered by dealer R out of 80. So 20 per 80. Ataupun you all boleh terus buat 1/4. Okay, 1/4 kecilkan pecahan tu, ataupun 0.25. 0.25. Okay, and then from dealer S, PS 50 over 80, and so for PT 10 over 80. And then each of these branches then were divided into the other 2 branches. Okay, kenapa 2? Sebab kita ada 2 probability lah. Sama ada dia rotten or not rotten. Rotten, not rotten. Rotten, not rotten. So untuk R, not rotten 0.03. Kat sini 0.03. So untuk not rotten dia akan jadi 0.97 lah. Okay, 1 tolak 0.03. So dia jadi 0.97. Form S, yang rotten 0.7. Okay, given. So not rotten is 0.93. And for T, rotten is 10%, which is 0.10. And not rotten 0.90. Okay, so dekat sini outcome dia adalah probability R and rotten. R and rotten is daratkan ni daratnya ni akan jadi 0.0075. R and not rotten, P rotten, S and not rotten, P and rotten, T and not rotten. So kita kirakan setiap satu ni. Okay, so back into the question number 2. What is the probability that the oranges delivered by dealers are rotten? Yang rotten, yang ni lah. Rotten yang this one, yang ni, yang ni, yang ni. So kita tambahkan semua. So jadi 0.0638. Question number 2. If it is known that, kalau ada if it is known that tu, dia punya probability dia ada palang kat sini ni lah. The oranges were in good condition. Good condition maksudnya not rotten kat sini. Okay, not rotten. Not rotten. Sebab it is not, it is known that good condition. So it is known that kita letak sebelah kanan. Okay, not rotten. Find the probability that they were delivered by dealer R. So ini yang kita nak cari. P, a probability of R not rotten. Okay, so yang ni lah. Ni. Ini guna ordinary formula yang first tadi, iaitu kalau insert into formula kita akan dapat P R intersect not rotten divide by P not rotten. Okay, so P R R intersect not rotten is right here. Okay, which is 0.2425 R intersect not rotten and then P not rotten kita boleh kira dia 1 minus rotten, which is rotten kita dapat daripada sini, ataupun nak cari P not rotten kita tambahkan yang ni 0.2425 tambah 0.5812 plus with 0.1125. So dapat jawapan tulis di bawah ni. So bahagikan dapat 0.2590. Or you can use Bayes theorem, okay, to find P probability of R not rotten. Okay, so formula dia akan jadi lain lah macam ni. Okay, so insert into the formula, dapat jawapan sama dengan guna ordinary formula. Okay, so this is the end of chapter 7. If you have any question regarding on this chapter, please ask me in Telegram. Okay, PM lah, PM secara personal. Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh.